How does a shear wall work? Shear walls are an important part of a house's lateral force resisting system. Wood walls are typically built like this, with a bottom plate, a double top plate, and studs spanning vertically in between. The studs are the main thing resisting the vertical loads on the wall. Most of the vertical loads come from gravity, which we have a pretty intuitive feel for since gravity is pulling on us constantly. The studs transfer the weight of the roof and everything that's in or on it down to the foundation of the house. But the house also has to be able to resist horizontal forces from wind and earthquakes, and that's where shear walls come in. A shear wall's job is to take the horizontal loads that build up in the roofs and floors of a building and transfer those loads down to the foundation. To do that, the wall needs more than just this framing. If we push sideways at the top of the wall would rack like this. We can keep that wall from racking by adding sheathing. Nailing sheathing to all the studs and the top and bottom plates of the wall locks all the studs together so the wall keeps its shape under horizontal loads. Now, if we push sideways, the wall doesn't rack, but it could still slide or tip if the load is big enough. To fix the sliding issue, we need a horizontal reaction force at the foundation. Adding anchor bolts from the bottom plate of the shear wall to the foundation provides this reaction force. Each anchor bolt contributes a little bit of the full reaction force we need. That's how the horizontal load gets to the foundation. To fix the tipping, we need some way of keeping the ends of the shear walls from lifting off the foundation. That's what hold downs are for. Hold downs are straps or big mechanical anchors that are designed for tension so they can hold down the end of a shear wall. Adding a strap that's embedded in the foundation on this side keeps the end of the shear wall from popping up, preventing the wall from tipping. To satisfy statics and keep the sum of the forces and moments equal to zero, an equally big compression force has to develop on the other end of the shear wall. Because of these big vertical forces at the ends of the walls, it's pretty common to see multiple studs packed close together there. One last thing to consider is that wind and seismic loads could come from any direction, so the direction of all these forces could flip on us. This means we need a hold down on the other end of the shear wall as well. That makes sure we've got both directions covered. And that's the basics of how shear walls work. Now, the next time you see a house under construction, you can understand a little bit more about what the sheathing and the straps are doing for the house.